Okay, good afternoon, children. Today we will discuss about amplitude modulated circuit. Let us go with the presentation. Okay. Emma, are you able to see the screen? Hello?
Yes, ma'am.
Okay, now. Okay, today we'll discuss about amplitude modulated circuits. Amplitude modulated circuits. Already we have discussed about amplitude modulator. Again, we will go through that one. So, what is modulation? So, simply we can say modulation is nothing but superposed high frequency carrier signal with low frequency signal. అంటే మన high frequency signal. What is high frequency signal? Which is nothing but carrier frequency, carrier wave. So, carrier wave లో మనకి high frequency signal ఉంటుంది. So, by mixing the high frequency carrier signal with low frequency signal is nothing but modulation. అంటే సింపుల్గా చెప్పాలంటే టు రెగ్యులేట్ టు అడ్జస్ట్ ద frequency signals is nothing but modulation. The modulation is nothing but superposed of high frequency carrier signal with low frequency signal. ఒక హై ఫ్రీక్వెన్సీ ఏదైతే ఉందో అది కెరియర్ సిగ్నల్ అంటాం. సో కెరియర్ సిగ్నల్కి హై ఫ్రీక్వెన్సీ ఉంటుంది కాబట్టి మనం మాడ్యులేట్ చేయాలంటే హై ఫ్రీక్వెన్సీ సిగ్నల్ అంటే కెరియర్ సిగ్నల్ని లో ఫ్రీక్వెన్సీ సిగ్నల్తో మిక్స్ చేస్తే యాడ్ చేస్తే దట్ ఈస్ నథింగ్ బట్ మాడ్యులేషన్. And amplitude modulation. So amplitude modulation is nothing but carrier wave amplitude change with instant change in modulation signal. Carrier wave amplitude change with instant change in modulation signal, which results in amplitude modulation wave. మనకున్న carrier wave amplitude it is changes with the instant change in the modulation signal is nothing but amplitude modulation. అంటే it results in amplitude modulation wave. Okay, let us see. Amplitude modulated circuit. We will see today amplitude modulated circuit. That means here the circuit which generates the amplitude modulation wave is called amplitude modulated circuit. The circuit which generates amplitude modulation wave is called amplitude modulator. మనకి ఏదైతే ఏ సర్క్యూట్ అయితే మనకి యాంప్లిట్యూడ్ మాడ్యులేషన్ వేవ్ని మనకి జనరేట్ చేస్తుందో ఆ సర్క్యూట్నే యాంప్లిట్యూడ్ మాడ్యులేటర్ అంటాం. మాడ్యులేటర్. సో ద సర్క్యూట్ విచ్ జనరేట్స్ ద యాంప్లిట్యూడ్ మాడ్యులేటర్ వేవ్ ఈస్ కాల్డ్ యాంప్లిట్యూడ్ మాడ్యులేటర్. యాంప్లిట్యూడ్ మాడ్యులేషన్ అంటే మనం చెప్పుకున్నాము. సో ఆ వేవ్ని ఏదైతే మనకి జనరేట్ చేస్తుందో ఆ సర్క్యూటే యాంప్లిట్యూడ్ మాడ్యులేటర్. So based on the power level of modulation signal modulator, based on the power level of the modulated signal, modulators are classified into two types. అంటే ఇక్కడ మనకి these modulated signal modulators they are classified into two types which are based on the power level. So here low level modulator, high level modulators. So what are low level modulators? So here the generation of amplitude modulation wave takes place when the power is at low level. అంటే మనకి పవర్ ఎక్కడైతే whenever we have low power level so that we will the amplitude modulation wave generation takes place. So those generation of amplitude modulation waves are nothing but low level modulators. అంటే మనకి ఎక్కడైతే పవర్ తక్కువగా ఉంటుందో అక్కడ మనకి యాంప్లిట్యూడ్ మాడ్యులేషన్ వేవ్ ఎక్కడైతే మనకి వస్తుందో దాన్ని లో లెవెల్ మాడ్యులేటర్స్. ఇట్ డిపెండ్స్ అపాన్ పవర్. సో అందుకే బేస్డ్ ఆన్ ద పవర్ లెవెల్ అని చెప్పుకున్నాం. సో బేస్డ్ ఆన్ దిస్ లో పవర్ వీ విల్ అబ్టైన్ లో లెవెల్ మాడ్యులేటర్స్. సో సేమ్ ఇన్ ద సేమ్ వే, సో వెన్ ఎవర్ వీ హ్యావ్ హై పవర్ లెవెల్స్, సో వీ కెన్ అబ్జర్వ్ ద జనరేషన్ ఆఫ్ amplitude modulation waves. So those amplitude modulation waves are nothing but high level modulators. Low level modulators based on low power level, high level modulators based on high power level. Now let us see the block diagram. So this is the amplitude modulation circuit block diagram. So here modulation అంటే ఏంటనుకున్నాము. సో superposed of or mixing of carrier signal with message signal or modulated signal. Carrier signal అంటే which we have the high frequency signal. Carrier signal లో మనకి high frequency signals ఉంటాయి. By mixing with message signal లో మనకి low frequency ఉంటుంది. So here adding of carrier signal with message signal so that we will obtain some modulation. Just wait. So by adding carrier signal with message signal or modulated signal, so up to an adequate power level. So ఒక పర్టికులర్ పవర్ లెవెల్ వచ్చేంత వరకు మనం ఇక్కడ మనం యాడ్ చేసినప్పుడు, సో హియర్ వీ కెన్ obtain the modulation wave. So here by adding carrier signal with message signal or modulated signal up to an adequate power level, so that we will obtain the modulated wave, so that the signals can be transmitted through the antenna. So this is simply block diagram of the circuit of the block diagram. సో కింద మనకి చాలా బ్రీఫ్గా ఉంటుంది. లెట్ us see. Now generating process of amplitude modulation. So the amplitude modulation, it is generated by two different types of modulators. So one is nonlinear modulator, switching modulator. So switching modulator acts as switch on off in the act of the. So here nonlinear modulator. So here we can observe the nonlinearity between current and voltage. So non-linear, linear lenity. So non-linear, not a straight. So here non-linear modulator. So which is a square law modulator, non-linear, or we can say it as square law modulator. So second one, it is switching modulators. So ivi manki, these are the two process of amplitude modulated waves. So these two are the low power modulated circuits. Rendu kuda based on low power level only we can obtain these two modulated circuits. So these are low power modulated circuits. So now let us see first one, non-linear modulators or square law modulator. Now, so it is a non-linear device. So here modulator is nothing but it is a device with non-linear relation between current and voltage. So here we can observe a non-linearity relation between the current and voltage. So now let us consider one of the non-linear modulator. So here this is the square law modulator. So here we have a carrier source and modulated signal and a non-linear device, band pass filters. So ఇక్కడ మనం ఆల్రెడీ చెప్పుకున్నాం కదా, కెరియర్ సోర్స్ ఆర్ హై ఫ్రీక్వెన్సీ సిగ్నల్స్ అండ్ మాడ్యులేటింగ్ సిగ్నల్. సో ఇక్కడ మనం తీసుకుంటే, సో దిస్ ఈజ్ ద సిటీ విచ్ ఈజ్ కెరియర్ సోర్స్ అండ్ దిస్ ఈజ్ మాడ్యులేటింగ్ సిగ్నల్, and this is high frequency signal, this is low frequency signal, and which is input. So v1 of t is nothing but x of t plus c of t. Ante by adding this carrier signal with this carrier signal with low frequency signal, which we can modulation takes place. That means v1 of t equals to c of t plus x of t. So here this is the input. Input is equals to c of t plus x of t, and these two are connected in series. So this carrier signal and the modulating signal, these two are connected in series, and which is the input. By adding these two, we will obtain this input voltage, and which is this input. And these are connected in series, and v1 of t equals to c of t plus x of t, which is connected to the non-linear device. This is the non-linear device, and here this is v2. And here this LC circuit, this acts as the tuned circuit to the particular frequency FC, which is acting as band pass filter. This LC circuit we can tune. So this tuned circuit, మనం ఇక్కడ tuned circuit తీసుకున్నాము. So this tuned circuit which acts as a band pass filter. That means this filter it filter all the unnecessary signals, and it send only carrier signal and LSB, USB. Only these three signals only it can pass. అంటే మనకి ఏదైతే అవసరమో అది మాత్రమే పాస్ చేస్తుంది. సో దిస్ ఈజ్ tuned circuit which is tuned to frequency, carrier frequency, which is acting as a band pass filter, and this is the V0 output. This is load resistance. So here V1 of t input, which is equals to x of t plus c of t. So V1 of t equals to x of t plus, ante ikkada manaki c of t carrier signal, modulating signal. So x of t plus, so carrier signal c of t, which is nothing but AC cos omega c t, which is equation number 1. So input output relation for non-linear device. So we have a relation between input and output relation. For non-linear device, it is V of 2, which is equals to A V1 of t plus B V1 square t plus C V1 3 t plus so on. So higher order terms. So here we will obtain higher order terms. That means V1 square, V3 square, V4 square, V1 cube, so V1 square, V1 cube, V1 power 4, V1 power 5, so on. So these are higher order terms we will obtain here. So here we will consider up to here. So input output relation for non-linear device V2 of t equals to a v1 of t plus b v1 square t plus c v1 cube of t plus so on. So here a, b, c are the constants. So substitute value of v1 of t. Already we have input v1 of t equals to x of t plus ac cos omega ct. So let us substitute this one here so that we will obtain by taking a outside. So v1 of t equals to x of t plus ac cos omega ct plus b v1 square means again we have to substitute the same and whole square plus so on. So we are neglecting here higher frequency terms. We are neglecting here higher frequency terms. So we have considered up to this square v1 square. So here if you see this one, so a x of t plus a into, if you multiply this one, if you multiply with a, we will obtain a x of t plus a ac into cos omega ct plus b into x square x t. Here we have a plus b whole square. It is in the form of a plus b whole square. So a square plus b square plus 2ab. A square means here x square t. B square means here ac square cos square omega ct, and 2ab means 2x of t AC cos omega ct. That means we are multiplying with b. దీన్ని మనం ఎక్స్పాండ్ చేసి if we multiply we will obtain 3, 4, 5 terms. So a square 2ab plus b square. That means we are expanding and we are multiplying with b here. So this is, so this here we have total 5 terms we have. Already we have neglected all these higher frequency terms. So here, out of these 5 terms, already we have fixed here band pass filter. So it filters all the terms and it sends only the carrier frequency signal, lower frequency band and upper frequency band. Already we have seen LSB and USB and carrier signal. So if you consider from all these terms only, that LC tuned that filter, it allows only term 2 and term 4, and it reduces all these terms. So it filters all these terms and it will send only second term and fourth term. So here in these terms only second and fourth are useful and remaining terms are not useful. That means it does not allow this modulating signal and this square modulation signal and this square carrier signals. It does not, the filter does not allow, only it allows these two terms. So we are writing which are not allowing by the band pass filter, not useful terms, and these are the which allowed terms by using that band pass filter. These are useful terms, these are not useful terms. So here that means this filter acts as the tuned frequency. It sends only the tuned frequency terms. It acts as the band pass filter and frequency of fc, and its bandwidth is equal to the 2 fm. So that band pass filter, its bandwidth it is 2 fm. So this band pass filter eliminates non-useful terms and it allows only all these useful terms. So output voltage which is equals to this one. Only useful terms will obtain because it reduces all these terms. It blocks all these terms. So output voltage V naught equals to this one. A into AC cos omega ct plus 2bx of t AC cos omega ct. And here omega c value is nothing but 2 pi fc. That means because here it is a frequency of carrier signal, so suffix c it is representing. So omega value 2 pi f. So we are replacing omega with 2 pi f. So a into ac cos 2 pi fc t plus 2bx of t ac cos, again omega value 2 pi f suffix c into t. So V naught T output voltage equals to A into AC. So that means here we are taking common as cos 2 pi FCT. So by taking this one, so we will obtain A into AC plus 2BX into T into AC. We are taking here common term as cos 2 pi FC of T. Therefore, V naught T equals to A into AC. Again, we are taking this AC also common. This first term we are taking common, AAC taking outside, and 1 plus 2bx of t, and AC already we have sent it outside. So here we don't have small a. That's why we are dividing with a, because we have taken common as a. So divide with a into cos 2 pi fc into t. This is equation number 3. So comparing this equation 3 with standard amplitude modulation wave will obtain. So we have standard amplitude modulation wave. It is delta t equals to AC into 1 plus mx of t cos 2 pi fc into t. So here in the place of mx of t, we have 2b by a. So 2b by a. Therefore, m value equals to 2b by a. So V naught of t, which represents an amplitude modulated wave with m equals to 2b by a. Hence, the square law modulator produces an amplitude modulation wave. Now, let us see the second one, switching modulator. So it acts as a switch. So switching modulator used a diode which is assumed to be operating as a switch. So here x of t and c of t. Here, if you see the circuit, x of t, c of t, which are connected in series, and input voltage here we have V1 of t. So V1 of t equals to this one carrier. This is carrier frequency, and uh, this is modulating signal frequency. So AC cos omega ct plus x of t, V1 of t. So amplitude of carrier, it is much larger than that of x of t, because carrier signal which have high frequency, that's why, and this is modulating signal x of t which have the low frequency. So amplitude of carrier is much larger than that of x of t. Already it is basics, and c of t decides the status of the diode on or off. So because this carrier signal have high frequency, so that it decides the either the switch it is in the state of on or off. The diode is on or off, which depends upon carrier signal, because it has the much higher frequency when compared with the, so amplitude of this carrier wave, it is much higher when compared with the modulating signal. So it decides the switch on or off. So V2 of t equals to AC by 2 into 1 plus 4 by pi AC x of t plus into cos omega ct plus unwanted terms. So here we can observe higher unwanted terms here. So this is the required amplitude modulation wave with m equals to, here we have 4 by pi AC. So this is for this switching modulator. Now let us see the advantages and disadvantages. So if you observe the advantages of the amplitude modulation, it is economical and it is easily obtainable, very low price, and it is very easily obtainable. So it is so simple to implement. So this is very simple to implement, which is using a few components. It can be demodulated. Demodulated means to retrace the actual original signals for the carrier wave. Carrier wave లో మనం ఎప్పుడైతే మాడ్యులేట్ చేస్తామో దాని యొక్క సిగ్నల్ స్ట్రెంత్ తగ్గుతుంది, సిగ్నల్ యొక్క ఫ్రీక్వెన్సీ తగ్గిపోతుంది. సో డిమాడ్యులేటెడ్ అంటే దాని యొక్క కెరియర్ యాక్చువల్ వేవ్స్ దాన్ని మనము తీసుకుని రావడానికి డిమాడ్యులేట్ చేస్తాం. సో డిమాడ్యులేటెడ్. సో a few components it can be demodulated. So the receiver of AMR in expensive. The receivers of amplitude modulations are inexpensive. Receivers matramo manaki expensive, very high cost. So disadvantages are efficiency is very low. Efficiency is very low. It declines the original signal quality on the receiving end. Receiving end దగ్గర దాని యాక్చువల్ సిగ్నల్ క్వాలిటీ మనకి తగ్గిపోతుంది. సో దిస్ మాడ్యులేషన్ యూజెస్ amplitude frequency several times to modulate signal by carrier signal. So we can use this amplitude frequency several times to modulate the signal by carrier signal. So these are the advantages and disadvantages.